So here are some additional learnings that you have to consider. So I have retrieved this from a research journal, and that research journal is known as the Pattern Recognitions, Volume 42, Issue number 5, and released last May of 2009. So here, this is a study conducted by Zhu and et al. Crease detection from fingerprint images and its application in elderly people. So you can find here the abstract. Conventional algorithms for fingerprint recognition are mainly based on minutia information, but it is difficult to extract minutia accurately and robustly for elderly people. Okay, so this is a study for elderly people. Just imagine your ridges due to old age are already worn out, and what you see are just the natural skin folds on older people. Okay, and one of the main reasons is that there are many creases on the fingertips of elderly people. In this paper, they have studied on the detection of creases from fingerprint images, in which we treat the creases as a special kind of texture and design an optimal filter to extract them. So they also have studied application of crease detection results to improve the performance of fingerprint recognition in elderly people, which include two aspects. First, it is used to remove the falsely detected minutia. Second, the creases can be treated as a novel feature for elderly people's fingerprints, which is combined with minutia features to improve the performance. Experimental results illustrate the effectiveness of the proposed method. Now, this is now the application of the science, wherein creases are considered as individual characteristics of elderly people. Okay, so here are some other research entitled Robust Crease Detection in Fingerprint Images. Same, the researchers are same people here mentioned here, and was a research sponsored by the Department of Automation in Tsinghua University, Beijing, China. Okay, so you can see here the various creases seen on elderly people, and using automation, using algorithm softwares, you can see here the plotting of red points that denotes perhaps the minutia locations and the exact location of the creases. This is what you usually do if you focus or try to be an expert in ridge analysis. Okay, so I do hope that one of you here or some of you here will be interested in this particular kind of job. Okay, so again, here are some other examples. In ridge tracing, we use the symbol P for plane world and then followed by its tracing. That's why we have here PO. P stands for plane world and then O is for the tracing, which is outer. Okay, so other examples. This is meeting tracing. Okay, and here a fingerprint or ridge analyst here provided two classifications, either a PI or a PM. Okay, I stands for inner and stands for M stands for meeting. Just do your individual tracing later on, then decide whether it is an inner tracing or a meeting trace. So here amidst COVID-19, so this fingerprint pattern remind us to smile even if we are experiencing a lot of problem due to the community quarantine and restriction of travel of people. So guys, just smile while watching this lecture video. Okay, so here is another example of tracing, and this is an example of outer. So by the way, this is a central packet loop world. Okay, so followed by another. This is a central packet loop world with an inner tracing. Okay, so look at that. Okay, so there are more than 3 intervening ridges there. Okay, so CI, so we have that CI, and we have DI. D stands for double loop, and inner. Okay, so another double loop, then this is outer. Okay, so tracing here, the tracing will be starting here going to this area. So there are more than 4 intervening ridges, or more than 3. So this is outer. Okay, so next would be another double loop word, and this is still out. Another double loop, and this is inner. Okay, so double loop, and this is an example of meeting. Okay, so another double loop. Okay, so this is another type of word, and this is classified as accidental word, and this is the symbol X and followed by its tracing, which is inner. Okay, another inner, and this is an example of an accidental word with meeting tracing. Okay, so there you are with our review on ridge tracing a whirl. Okay, again, let's go back to this table. Then we have to use a symbol of double X for missing or amputated finger. Okay, so remember that we will not use or adopt the opposite finger using its pattern like we have done with the Henry classification formula. In cases of missing or amputated finger, we will just use the code double X. This means either amputated or a missing finger. And we will use SR for patterns that are completely scarred or mutilated. Okay, so there you are. Okay, so these are basically same rules mentioned by your reference book, Fingerprint source book. So just read on the Fingerprint source book, and you can find here 4 additional rules that you can use in deriving the NCIC formula. Okay, remember rule number 1 to rule number 4. Okay, so let's look into some examples of amputated fingers. I'll be using the fingerprint card of John Dillinger. Okay, you know pretty well John Dillinger. Okay, John Dillinger is already dead. Okay, he had a shootout with the FBI, and he eventually died and killed by special agents last July 22 of 1934. So in here you see an obvious alteration of his ridges because of alleged use of hydrochloric acid. A doctor who was involved in illegal drug trade have helped John Dillinger hide his identity. So after performing surgical operation to modify his facial features, he also helped John Dillinger erase some of his friction ridges. But eventually, when he was killed by agents of the FBI, it turned out that some of his ridges are still intact and could still be analyzed, and there are still significant features that could be essential for fingerprint identification. Okay, so here is another fingerprint card of John Dillinger, and you notice that in here his ridges are still intact, no damage. And look at his fingerprint classification in there. Okay, so we have here primary classification of 9/14. Then we have a secondary classification of R over U, and there is an incomplete data here for the subsecondary classification, and this is for the final classification, and we have here the key classification. You notice here that there are no major classification. Let's go back to the earlier fingerprint card. So this is the fingerprint classification provided by the fingerprint examiner after taking his post-mortem fingerprint card. Okay, so you can see here a different fingerprint classification formula. Here a major classification of O over O, primary of 32/32, and we have a secondary of W over W, and so on and so forth. Okay, so basically different from that of his ante-mortem fingerprint card or fingerprint classification. Okay, so let's move on with some few examples. Okay, so we have here the given information. Okay, so for right thumb, we have ulnar loop with a ridge count of 12. And for the index finger, we have a double loop whirl with outer tracing. For the right middle, we have an ulnar loop with 11 ridge count. And we have a right ring finger, a radial loop with 16 count. And we have the ulnar loop for the right little finger with 14 ridge count. Okay, that's the information provided for the right hand or the right fingers. Let's proceed with the fingers 6 to 10, which represents the left fingers. Okay, left thumb, we have ulnar loop with 27 counts. Left index is a tented arch. Left middle is amputated finger. We have a left ring finger here with an ulnar loop, and the left little finger is a central packet loop with an inner tracing. Let's apply the rules of the NCIC. Okay, so for the right thumb, we are going to use the rules, and since this is an ulnar loop, then we will just write, well, basically the ridge count. And for the right index finger, since this is a double loop word, we will use D, then followed by O, so it's DO, and so on and so forth. So this will give us an NCIC classification provided here. Okay, 12 for the right thumb, DO for the number 2 finger, 11 for the right middle finger. So since this is an ulnar loop, so it remains the same, 11. Okay, you notice here that we have 66. Okay, this is applying the rule. Okay, 16 ridge count plus the arbitrary number of 50, so that will give us 66. Okay, so pay attention with this radial loop. Okay, so radial loop here is very special. Okay, like in the Henry system, radial loop is part of the small letter group. Plain arch, the radial loop, and the dented arch, since they belong to the small population of fingerprint pattern. Then another ulnar loop, which is 14, another ulnar loop, which is 27. Okay, so you notice that if you code ulnar loop, they are basically less than 50. Then if you code a radial loop, they are always more than 50. Okay, so just remember that. Then we have here double T. This represents dented arch. Then you notice here we have applied the double X for amputated fingers. We don't adopt the opposite finger. So in case that you adopt the opposite finger, it becomes an ulnar loop. So we don't do that here in the NCIC. We only do that for Henry classification formula. Then we have the left ring. We have 17 and followed by CI for central packet with inner tracing. So this NCIC formula is much easier than the Henry classification formula. Okay.